Today I will talk about machine learning the product at Spotify. I'm Boxun Zhang. I've been with Spotify for almost 4 years as a data scientist. And one of the recent focus I have is to model and understand users' retention behavior. I'm not really sure if the term retention is familiar to you guys, but I mean, in short, retention means we want to understand, why user after they sign up, if they come back or not, and what are the factors driving their retaining behavior. And also in the past, I've been doing all kinds of user behavior measurement and behavior modeling as well. Before joining Spotify, I was doing my PhD in computer science from Delft University of Technology in Netherlands, where I studied user behaviors in BitTorrent, the peer-to-peer file sharing application. So some time ago, I read an article about how to make a good public speech about this kind of research work. And one thing I learned from that article is that you probably only want to deliver one message to the audience. So the message I want to deliver today is here, which is A/B testing is a popular method for learning your product. However, the traditional A/B testing techniques are kind of insufficient for learning from your A/B test. That means in companies, when people invest their resource doing A/B testing with the traditional method, they actually kind of waste some lots of insights or learnings from those things they've done. Therefore, in this presentation, I will introduce a different method used at Spotify for analyzing A/B tests, with the goal of maximizing the learning from those tests and also trying to figuring out the underlying causes of the effect in A/B test. So I think everyone would agree that if you run your business, no matter what kind of product you have, either it's a web service or it's a mobile app, learning your product is kind of crucial for a couple of reasons. So the first one is the most basic reason, which is measuring the performance. We want to understand the basic performance of the product, how many users are using that, how many users actually click through a certain button, how many people purchases your goods. The second one is identifying problems, because there's no such thing called perfect product. We always have problems. And lots of problems can be identified from data, by having proper measurement in place. And last, we also want to discover opportunities from data or from the product. So, we might discover some undiscovered patterns of users using, certain features in the product that might lead to future product improvement. And also in the industry, everyone kind of agree that A/B testing is actually one of the more affordable and feasible approach to learn your product, because it's very easy to control. I'm not sure if this statement holds in this room. Everyone, so how many of you know A/B tests or have done A/B testing before? Okay, so it almost holds. However, I would say, so everyone knows about A/B testing, more or less, because there are so many tricky things and traps in the whole process. And for most of the time, I think people get A/B testing wrong. But in short, to do an A/B test, you start with a hypothesis. And the hypothesis can be anything related to your business or a product. For example, for our case, we can say, this is completely hypothetical. Switching the color from green to pink might increase retention by 10%, which would be great if it happens. And also, you have your user base. Hopefully, you have lots of users, so you can divide user base into control and test. Then you can develop some corresponding change in your product according to the hypothesis. For example, switching the color on the button. And apply that change. We're rolling out that product to the users in the test group. And wait for a period, wait for some time until all the users have tried it out. And then you can measure the effect of the change in the product in the test group by applying all the traditional A/B testing techniques. And what people essentially trying to get is, by doing A/B test, is setting up the link between the change in the product and the effect on the users in the test group. And we want to ask this question, is this good enough by having this link? Since I'm already here talking, so probably you can guess our answer at Spotify is no. The reason is, with traditional A/B testing techniques, we can only learn from A/B test in a rather superficial way. What I mean by that is, we can always measure the size of the effect, or if the effect exists. However, for many cases, we don't really know the cause of the effect. We see something happen, but that's probably it. We don't really know what's going on. It's caused by a couple of reasons. So first, product can be very complex. Especially nowadays, there's a very strong tendency of, having more and more features over time in the product, but we rarely see that, companies like cutting off features from their product. People always have more and more things in there. And sometimes it can be as complex as this. As a result of the product being more complex, the user behavior will also be more complex as well, because users will generate more and more interactions with the new features, with more features, and also they will discover over time new ways of using the product. And another thing about users is, everyone probably will admit that it's just so hard to predict user behavior in general. And at Spotify, we also don't really have all the pieces of information we need to understand user behavior in a more general way. For example, we would like to understand if a user is commuting, is studying, or is just having a dinner with their friends, so we can provide better recommendations to our users. However, we don't really have those information. And also, sometimes we as people, running the A/B test also complicates the problem a little bit by introducing big changes into our product. So this is something not suggested or recommended by the A/B testing textbook at all, as you should always introduce very small, manageable changes so we can isolate out lots of factors. But sometimes, we're maybe rushing towards a deadline, so we have to pack a few things together into a big change. As a result, the link between the change in the product and the effect in the users in the test group might not be that obvious. So it becomes like this. So we have the product change. And such change will lead to many changes in user behaviors, all kinds of behaviors. And it's the user behavior changes actually lead to the effect in the test group. So the effect we can observe. Now we want to ask a different question. Among all those behavior changes we can imagine, so which one actually has the biggest impact on the effect? So for my work, the effect is retention, short-term retention. We want to understand which user behavior or which kind of, which aspect in the product actually lead to either better retention or worse retention. And later on, I will show how at Spotify we can approximate the impact of those behavior changes with their predictive power to the effect. And you might notice that this is really a problem involving a high-dimensional data space. As for a product like Spotify, introducing one change, we can lead to maybe dozens of behavior changes in the product. And figuring out the relationship of all those small changes to the effect, like the retention behavior, is not that trivial for our brain, even though our brain still outperforms most of the deep learning models in other tasks, but still not good at this thing. However, the machine is designed for this, so we have machines. Especially with more traditional machine learning models, it's basically designed to figuring out the more complex correlations in high-dimensional space. So our solution at Spotify is converting the A/B testing problem into machine learning problem. In this way, we can leverage the power of machine learning models to reason out the underlying correlations and causes. It's a rather straightforward solution, I would say. So I think it has only 3 steps. So the first one is, of course, we want to determine the type of the problem in the machine learning term. So we have classification tasks, which covers things like retention, conversion, which means when users convert or, let's say, switch their account from free to premium. And also we can do things like understanding the click-through rate of certain links or buttons. We also have regression tasks, which covers things like users' lifetime value, which is extremely valuable for any business. And also we can understand session length of users, why some users have longer session length and some others have shorter ones. And in the past, I have been focusing mostly on the classification problem, particularly on retention. And I personally think this is a relatively easier task compared to regression because it doesn't have to give out very accurate prediction of the actual value, but instead it just gives out a binary prediction, yes or no. So the second step is to prepare a user-level measurement. So that means we need to jump away from the group-level measurement for traditional A/B testing to the user level. So if you think about the retention problem, when we do A/B testing, the only thing we need to measure from our data is actually just their occurrence in our system. We just count if a user occurs in Spotify in one time period and if that user shows up later or not. So it's extremely, let's say, rough or simple measurement. So we don't need more than that. However, to leverage the machine learning model, we have to prepare proper user-level measurement. That means when we see the behavioral changes, or when we have a list of behavioral changes we think might impact the effect, we need to come up with a set of proper measurement reflecting those behavioral changes. And then those measurements will help us to build a machine learning model to reflect the target, which is the user-level representation of the effect. So for retention, on the group level, we have the ratio, which means how many users got retained. On the user level, we actually have a 1 or 0 situation, if a user comes back or not. And one thing to notice that is very, very often we have much, much more measurement than the set of behaviors we want to understand. Because for each specific behavior change we want to study, we normally can come up with a loss of measurement about that one particular behavior because we want to reflect different aspects of that behavior. And naturally, we can later on convert all the measurements we have to machine learning features. So that's a rather trivial step. And also at Spotify, we make a differentiation between actionable features and non-actionable features. So actionable features are the features reflecting user behaviors that we can influence from our product by changing our product. Things like session length, skip rates, offline streams. We can always influence them by putting new stuff in the product. On the other hand, we have non-actionable features, which are features about user behaviors that we cannot change or user characteristics we cannot change. For example, country, nationality, age, gender. I don't think any internet-based product can really change those things. And the reason for us to make such differentiation is that we want to use those features in different ways. For actionable features, we want to use them to build machine learning models into the actual training the models. And for non-actionable features, we actually use them to segment our user base. And as a result, given our large user base, we have lots of smaller segments, and within each segment, we train a machine learning model. So that gives us better machine learning models because it's normally it's more accurate, and also it makes the interpretation of the machine learning model easier because we are actually taking out lots of features from that. And you can see that this is essentially the feature engineering step for all kinds of machine learning problems. And for this approach to work at Spotify, we actually need a quite rich and comprehensive feature set. And I can't really emphasize more on the importance of this step for, in general, for machine learning. And As Pedro Domingos said, some machine learning projects succeed and some fail. What makes the difference? Easily the most important factor is the features used. So at Spotify, when we were developing this framework, we actually spent a huge amount of time and effort developing our user session data, which consists lots of user events, from our measurement. And based on that user session data set, we actually developed lots of machine learning features on top of that. And at a certain point, some of my models actually used around 500, even 600 features from that data set to understand the retention behavior. So I would say if you decide to try out this approach, do spend proper effort in this step. And once you have a well-made, let's say, feature set, that will give you lots of long-term benefits. And now, naturally, we want to make a selection of the model. So for classification or retention, there are so many different machine learning models we can use, from linear models to even deep learning models. So our choice of model at Spotify is gradient boosting machine, the GBM model. And the implementation or the library we have been using in the past 1.5 years is XGBoost. In my opinion, this is a much better variance or improvement over the original GBM model, both in terms of execution efficiency. It can run single node distributed way as well, and also in terms of predictive power from XGBoost. And for some of you who are familiar with the Kaggle competitions, you might know that this XGBoost used to be almost like the standard for winning Kaggle competition before the deep learning models come to the scene. But I want to say, at Spotify, we're not doing a Kaggle competition. What that means is prediction is not really our goal. We're not really, striving for having super accurate models like Ox-score 0.98, 97 or something. So what we want to have is models that have reasonably good predictive power. It should always be significantly better than random guess. That means the model does provide us useful information from the data. So once we have that model, that performance, we are okay. What we are really into, or what we are really after, is the feature importance, also known as variable importance, which is a quite simple measure about how a machine learning feature is contributing to the accuracy in the model in GBM and also in random forest. So in the XGBoost implementation, the feature importance measurement is calculated as the improvement in accuracy brought by a feature when the model branched the feature, at a certain point, and then the improvement in accuracy in one tree will be summarized over multiple trees. And now we are almost done. So we have our model trained and validated. We have a list of features. We have their importance scores. And naturally, the features with the highest importance scores will be the ones we want to look into. And those are the features have the highest correlations with the effect with the target. And at this moment, we are not having the causation information, we only have the correlation. So we want to examine the top features. One simple thing to do is to compare those features, their distributions between test and control, and get an overall feeling about how they look like. And another thing we find very interesting and useful is once we identify those very important features from the model, we can actually work on those top features in the later stage and derive more informative high-level metrics, even on the user-level metrics. And those metrics will be used for future A/B testing as supporting metrics, besides company key metrics. And also sometimes we find out, once we train the model, the first model is out, we examine the top level features, we realize, those top features are not that actionable, and we want to understand why certain top features are behaving like that. What are the factors causing such behavior in those top features. And then we can make this process iterative. We can build new models trying to, using other features, not the top features. And top features will be the targets. And the model will be helping us to understand what other features, have bigger impact on the top features. So the process is more like, peeling the onion. So we try to get down to the bottom of the problem, slowly. And to a certain point, we say that, okay, the top features we identified from the model can be used by product. We can take actions. So I want to discuss a little bit about the model selection. And so we are certainly not using linear model for this problem. As we believe that linear models have rather weak predictive power, and also it's not really robust in a way that when your data have lots of skewness, outliers, non-linear relationships among across features, and also correlated features as well. So there's lots of pre-processing work needed for linear models, which we don't really want to do, because the way we design our features are is to make sure the features will reflect user behaviors, the user behaviors we are interested. And we certainly don't really want to drop the features when we train some models. We want to keep all those features in the model, so that the model figure out how it works. And also, we're not using random forest. And so compared to GBM, random forest probably is even more popular, as it requires less parameter to tune. It's less prone to overfitting as well. That's true. We did spend quite some effort tweaking the GBM model, traversing the parameter space to figure out, what's the best combination of parameters. And the reason for not using random forest here is the calculation of feature importance is biased or is inaccurate for random forest. And this is caused by the way random forest is trained, because when training the random forest, all the trees are trained at the same time, and training features are sampled randomly across all the trees independently. So assuming that you have strongly correlated features, and the chance of those features being selected or chosen by two different trees are probably quite equal. And in that way, the feature importance you get from those features will be somehow watered down or underestimated compared to a GBM model, because in GBM, trees are trained in sequence. So once a tree picks up one of those correlated features, and most of the importance will be assigned to one particular feature instead of sort of evenly distributed across all the correlated features. And of course, there's a solution for that. There's a paper listed on the bottom of the page. They have a way to control the correlation among features, so you can get the correct feature importance. But from what I understand from that paper, the calculation of the corrected or unbiased feature importance from random forest is still somehow slow. So we don't really want to switch from the super fast XGBoost model at this moment. And so far, we have been using this model at Spotify for quite some time, maybe in the last 1 year or 1.5 years. And we have been applying this model for some of the important questions or areas we want to understand. For example, the activation of users, which happens right after the sign up of new users, and also retention, both short-term retention and long-term retention, and also churn, which is on the other side of the retention problem. Sometimes users just leave the product and never comes back. We want to understand why. However, that being said, this is certainly not the ultimate solution for the problem. So we still have lots of puzzles, at Spotify we want to solve, and we also believe that this machine learning approach is only the first step of the problem, because the model will actually help us to discover lots of new problems, and then those problems actually require rather different techniques or models to solve. And we're also constantly seeking out collaboration with academia, and also in the past we have been taking master students and PhD students in-house, and also we are hiring data scientists to our team. So feel free to reach out if you feel interested. And that concludes my talk. Thanks.
Thank you so much. And some questions perhaps we can start with. And I'm starting to figure out how this thing... Exactly. I'm starting to figure out how these things work. The blue boxes are for Vijay. The green box is for you. Can you give a concrete example of an effect, a behavior change, and the set of measurements used to measure it?
So in effect, as I said, a concrete example could be a change in retention. Let's say short-term retention. For example, now we have X% of users, retain over 2 weeks or 4 weeks, and by applying some changes in the product, we can say, we have extra delta percentage increase in the retention. So that would be a huge thing for all the internet companies when they see a jump in the retention. And that actually will trigger lots of questions from the product side, because people do want to understand what are the behavior change actually caused that thing. And in Spotify, we care mostly about users' streaming behavior. So when it comes to streaming, we care about their, for example, number of sessions they have, the length of the session, the arrival time of their sessions. And within each session, we care about how many streams they have, the streaming time or the streaming progress they have, skip ratio, all kinds of things. And besides streaming, we also have other events. For example, how users explore the app, how many different pages they visit, and which is the page or the view they spend most of their time trying to figure out their interest. And also on the free tier at Spotify, we also trying to figure out what are the impact of some of the limitations we have on the free tier have on user behavior. For example, ad, how ad will affect users streaming. Does that actually impact user behavior or not? We're still trying to figure that out. And the set of measurement actually are from our user session data. As I said, our user session data basically have all those, covers all those behaviors or actions as just described. And from there, basically we have, for each single user we have in Spotify, we have all their sessions and all their events. And from there, we can just derive all kinds of measurement needed for different models. We certainly don't use one fixed set of features for different models. We basically change the set of features all the time.
All right, thank you. So perhaps we can take the next question as well. How large is a typical A/B test in terms of users? Or for me as a Spotify user, when I open the application, how likely is it that I'm part of a test?
It depends. It depends on the type of test, and also depends on the platform. Mm-hmm. Since you are already a user on Spotify, so for lots of tests we run only on new users, probably very unlikely you will be included. If you are there, probably we made a mistake. But I would say, since Spotify have quite a large user base, normally for one particular test, we don't have to include large percentage of users in the user base. Normally we say 5% probably is okay to reach any sort of statistical significance. And however, if we say something is super important, we want to apply this approach. We probably want to have slightly more users there, so we have more training samples for our machine learning model. So we certainly don't want to limit ourselves by, let's say, 50,000 training samples for a rather complex machine learning model. So it really depends. But I would say, since we are running lots of tests, so the chance of you being included in at least one test probably is rather high compared to a single test.
Yeah. All right. Let's continue with some of these questions, actually. Do you consider data sources from outside of the product? I'm trying to understand users. I guess something from outside of your system, basically.
We do, actually. We do. I think we have been trying to, one example I can give, maybe it's not so relevant, is weather data.
Weather?
Yeah, weather data. We tried. It was part of the research effort we had at Spotify. It's also fun. We try to understand. Assuming that we have accurate enough weather information, would weather actually affect how users stream. For example, if that's like stormy weather outside, if people are just like stranded indoor, and do they stream differently than a super sunny, awesome Swedish summer? Probably yes. But we don't really have any sort of concrete findings yet. Probably it's very hard since there's so many other factors affecting user streaming behavior. But also, a more relevant example would be Twitter data.
Yeah.
So we want to understand the sentiment of Twitter users on Twitter, and also we have a team getting information from Wikipedia, so we can get more information about our artist, which is something not so easy to get, because we do want to have very solid ground truth of artists and all the proper big albums and big releases.
Yeah. All right. Thank you.